I sometimes wonder how to protect the nature for our kids or the coming generations. I have an idea. My friend Lucy is a scientist working on renewable energy. I will request her to introduce our kids to renewable energy. Lucy, I wanted Joey and Rachel to be more conscious about the environment. And then I thought of you. Since you work with renewable energy, can you help them by telling them something more about it?
Sure. I will be honored to do so. I am happy for you and your kids' concern for nature.
Hello. I welcome all of you to National Center for Solar Energy.
This place is awesome.
Thank you, Lucy, for bringing us here.
Before I take you to the laboratory, I need to tell you about a few rules. We will have to wear a protective dress, as we will go in a clean room and we need to maintain its cleanliness. Come on. Let's go.
I can't wait any longer. I am so excited.
As I have already told you, solar cell converts solar energy into electrical energy. What we usually see in the fields is basically a solar module which consists of an array of solar cells, which means a number of solar cells connected in series and parallel to each other. This is done so that the required current and voltage can be drawn from the module.
What are these solar cells made up of? How to make a solar cell?
That is exactly what I will be showing you today. There are many different materials which can be used to make a solar cell. For example, silicon, germanium, gallium arsenide, etc. But in our laboratory we mainly use silicon. Silicon is primarily obtained from sand. It is prepared in the form of ingots, which are cut into thin silicon wafers. Silicon is a semiconductor, which means it normally doesn't conduct electricity like metals. They behave as insulators. But in case of any incident energy, like thermal energy or light energy, they start behaving as conductors. The electrons start moving in the semiconductor. When electrons move, they leave a hole or vacant place behind. A semiconductor with excess of vacant places, that is holes, is called p-type, and semiconductors with excess of electrons are called n-type. In a solar cell, a p-type substrate is taken, and n-type layer is diffused into it. When sunlight falls on this structure, then electron-hole pairs are generated throughout the structure. Excess electrons are collected from the top and passed through a circuit and then back into the structure. So, you can see that in a solar cell, you do not need any external power. Instead, you can generate power using it.
It seems slightly difficult.
Don't worry. You will get it when you start studying semiconductors in your class.
Yeah. Till then you can see how we fabricate a solar cell. We need the solar cell to capture as much light as possible. So, we begin with texturization of the p-type silicon wafer. When light is incident on a plane surface, a lot of light is lost due to reflection. But when pyramids are formed by texturization process, light gets internally reflected and hence captured within the device. The texturization is done chemically. Next, the textured silicon wafers are taken in a batch and put inside a diffusion chamber for inserting a n-type layer on the top surface of p-type substrate. This process is done at a very high temperature, in presence of gases like Pol-3, nitrogen and oxygen. An unwanted phosphosilicate glass PSG layer is formed during this process, which is chemically removed. Next, the front and rear surface is electrically isolated by removing the surface layers by either plasma or chemical etching. In order to further improve light trapping, a silicon nitride layer is deposited on the structure in vacuum chamber called plasma enhanced chemical vapor deposition (APECVD) system. Now, the solar cell structure is ready. We just need to make contacts for external circuit. This is done by a method of screen printing. The wafers are placed on a stage, and then metal pastes are printed through a screen with the pattern of contacts which we design. Finally, the cells are put in a furnace with very high temperature, so that the metal can make good connection with the semiconductor. Now the cells are ready for testing. The current and voltage is measured by a solar simulator. It is called so, because the light incident is similar to that of the sun. Many other characterizations of the cells are done to find the quality of the cell. Let me finally summarize all the steps. First, we start with a p-type silicon wafer. It is then texturized chemically to enable more light to go into the wafer. Then, we go for diffusion to form a N layer on the top. G formed during this time is removed chemically. We then isolate the edges to avoid shorting front and rear surface. Next, we deposit another anti-reflection coating to further reduce reflection from front surface, and finally we go for making front and rear metal contacts. After this, the cell is ready for testing.
Wow, this is so wonderful.
Lucy, I can't thank you enough for showing this to Joey and Rachel.
Yes, Mom. This is so interesting.
It is my pleasure to have you all here.
I hope you liked the video. Don't forget to like, share and subscribe. Goodbye.